Alright, welcome to the experiment on the cycles of copper here at Chemistry 1A03 or 1E03. So today we're going to be working with some copper and we're going to be taking you through various transformations. I'm going to show you a little bit about how this experiment is going to run during this video. First thing you want to do when you get to the experiment is get your hot plate going. Okay? And you want to get a nice big beaker and put 250-300 mils of water in it and get it warming up. Now what you can do is, you don't need to put this at 100 degrees, you can put it up to 350-400 degrees. You just want to make sure it warms up nice and quickly. You can leave the beaker there because you're going to use it a couple times during this experiment. Okay? So very important to get that water going right away so that when you need it, it's ready and you can proceed on nice and quickly. One thing to note about this experiment is, in the 2.5 hours you have to do it, there's a lot of steps to be done. You need to be very efficient with your time and not waste extended periods here and there just by waiting for things to happen. So try to plan your experiment out as best as possible. So the first thing I'm going to do is, I'm going to get on my gloves. Of all the experiments we do here in first year chemistry, this is the experiment where we work with some fairly harmful chemicals, namely concentrated acids and bases. So please make sure you're dressed appropriately, you're wearing gloves at all times, and you're working safely. So I've got my water going. What I'm going to do is, I'm going to go over to the balance and I'm going to get some copper turnings. So we're to get 0.25 grams of copper. So I'm going to put the weigh boat on the balance. Wait for it to stabilize. I'm going to tare. It's going to bring it down to 0 grams. Now I'm going to slowly add some of the copper turnings. The easiest way to do this is, take a bit of the copper, gently put it onto the weigh boat. You want to get up to about 0.25 grams. I went over a little bit and I'm at about 0.3 grams. That's fine. You don't need to have exactly 0.25. What you want to do is make sure you accurately record what the weight was, because you're going to use that for your yield calculation afterwards. Please also make sure you're nice and clean. If you spill the copper everywhere, please tidy it up. Close the doors to the balance. And I'm going to come back to the fuming, and I'm going to start the experiment at this point. So the first part of the experiment is, we're going to take our copper and put it in one of the beakers. Make sure you get all the copper off of the weigh boat. The next step is to take a concentrated nitric acid. You can add about 3 mils of this to the solution. Try not to add too much. You're just going to have to neutralize it with sodium hydroxide afterwards. If you add too much, it's going to take longer in your second steps. Be very, very careful with the concentrated nitric acid. It's very dangerous. So I'm going to take, at this point, about 2 milliliters of our concentrated nitric acid, and I'm going to just pour it on top of the copper. What you should be seeing here is, it's going to a nice green color and a brown gas is being evolved. Now, it's extremely important to do this step in the fume hood. For the majority of this experiment, you're going to be working in the fume hood. Any of the chemical reactions done in the fume hood, to make sure that all of the gases that are let off are vented properly and you're not putting yourself in harm's way. This reaction, or this step, it's not very long. What you're going to notice is, the copper is going to be reacting very, very quickly. As soon as the copper is done reacting, you can move on. So you're going to see copper is going from a solid state, it's being reacted, it's being oxidized, and it's going into an aqueous phase. So there's no more copper left in the bottom of the beaker. I'm ready to move on. This step doesn't take 5-10 minutes. It's usually done within 30 seconds. I'm ready to proceed. Now this is where it's beneficial to have your hot water already warm, because that's what we're going to add to the next part of this step. So to take the hot water, the easiest way to do this is to take one of your J-cloths or potentially some of the paper towels, and you're just going to wrap it around the edge. Okay? And it makes an effective handling. So you're going to add in some of your hot water into your solution, put it back on, and now you have your copper nitrate solution that you've made. And you've added some water, we're ready to go on to the next step. Okay? So the next step that we're going to do is, my water's starting to boil at this point, so I'm going to turn it down a little bit. you're going to add some sodium hydroxide. So this is going to be the next step. Now, make sure during all these steps you're taking good observations in your notebook. So every time you do something, every time there's a physical or chemical change, you're recording it well in your notebook. A lot of this experiment is based on your observations. You're expected to take very, very good detailed observations, so make sure you're doing that. So the next thing I'm going to do is I need to add 20 mils of my sodium hydroxide to this solution. Okay? Now what's going to happen is I'm going to be taking my sodium hydroxide. When sodium hydroxide reacts with copper nitrate, it forms copper hydroxide. Copper hydroxide is unstable at high temperatures. Okay? So we're going to go through a couple various stages. Now, for this step, you're welcome to pour the sodium hydroxide into your graduated cylinder. So I've got 20 mils. I'm going to add it in. Okay. What you're going to notice is the first step is you get a blue color, okay, and you start to get a precipitate. As I stir this, it'll begin to go black. So the first color is forming the copper hydroxide, and the second step, as it goes black, is forming the copper oxide, as the copper hydroxide decomposes to that copper oxide. Now, what would normally happen is I would need to heat this to make sure the reaction went to completion. Because my water was warm, the reaction took place in one step. So normally you would put this on. Now, whenever you put a solution that has a precipitate in it onto a beaker, what you want to do is make sure you're stirring it as this is happening. If you don't, you're going to get ineffective heat transfer. And a lot of times you'll get what we call bumping in the beaker, and it'll break the beaker. So if it's on the hot plate, I'm going to stir it. But because my water was so warm already, I don't actually need to heat it. It's done. When you look at this, there's no green color left of the solution. It's all a brown-black precipitate. It's ready to move on. We've actually formed our copper oxide. So we've gone through the steps of copper nitrate, copper hydroxide, copper oxide, literally in a few seconds. So I'm ready to move on to the next step. So what we're going to do now is we're going to let that settle because we need to decant it. So we're going to give it maybe 2, 3, 5 minutes to settle down so we can decant it. The purpose of the decanting is to get the basic solution off. So right now, there's a lot of sodium hydroxide left in there. We want to get rid of the sodium hydroxide, so we're going to decant off the sodium hydroxide solution, wash it with a bit of water, decant that off, and we're going to remove a lot of the base because the next step is going to be adding acid. We want the acid to react with the copper, not with the leftover base. So I've waited maybe 3 to 5 minutes. Doesn't take a long time. And if you look carefully, we've settled a bit of the copper oxide down to the bottom. This doesn't need to be perfect. Well, again, what we're trying to do is just get rid of some of the solution. So I've got a waste beaker here, and I'm going to slowly decant or pour off the liquid on top of the copper oxide. Now, odds are you're going to lose some of the copper oxide, and that's absolutely fine. Okay? If it happens, it happens. So I'm going to get most of the liquid off, trying to leave as much of the copper oxide. But if I lose some, that's all right. So what I would do now is I would add more water to this, let it decant and settle again, and pour off the excess water, give it a second rinse, and then we move on. I've already done that, so what I'm going to do now is I'm just going to move on to the next step. The next step is to take some sulfuric acid, 6 molar, and we're going to add it to this solution. We're going to do another transformation with the copper. Again, be careful, concentrated acid. I'm going to take 10 mils. Because it's a smaller graduated cylinder, and it's only 10 mils, I'm just going to pipette this out. It doesn't take very long. It's a lot easier than pouring it. A lot of times the chemicals for this experiment may not be in your fume, but I've set everything up here just for the video. You might have to go to the front of the room and get the chemicals and come back, or go get them in your Erlenmeyer or your graduate cylinders. So what we're going to do now is I'm going to take my sulfuric acid. We have our copper oxide solution, and I'm just going to pour in. And you'll notice that the black color goes away, the black precipitate goes away. We have a blue solution again. Okay, so you can go through and explain through your chemical reactions what's happening in this case. The next step we're going to do is, we have our copper solution here. It's back in solution, it's an aqueous solution. What we're going to do is we're going to add in some zinc and do a little bit of redox chemistry. So I need to go through, and we're going to go back to the balance. I'm going to get 2 grams of my zinc. So I'm going to take one of the weigh boats, tare, wait. Sometimes if it's not tearing, it helps to close so there's no wind going through. Back carefully, no making a mess, please. Get 2 grams of zinc. Now, this step doesn't need to be accurate. You're going to be using excess zinc anyways. So, as long as you're around 2 grams, it's not that significant. So now we're going to take our zinc and we're going to pour it into our solution with the copper sulfate. Okay. What you're going to do at this point is you're going to slowly stir it. Now this step is going to take a little bit of time. Just gently stir it. What you're going to notice is a chemical reaction is going to happen. You're going to be reducing down the copper 2 plus with the zinc, so you're going to make zinc 2 plus and copper 0. So we're going to start to make our metallic copper back. So it's difficult to see, but if you were to look in here, and you'll notice this more when you're doing it, you're going to start to see the brown color of the copper start to reform. The zinc was silver in color, and the copper again is some brown. So you're going to keep on doing this until it looks like there's no more copper coming out of the solution. So this might take 3 to 4 minutes. You can definitely see at the bottom of the beaker now, there's like a brown color of your copper. So I'm going to keep on stirring this in another couple minutes. And when it comes back, we'll start to do it. As you can see now, all of the zinc is reacting with the copper. We know that, we know it's done when the blue color from the copper solution is completely gone. So there's no more blue color in the solution, so we know that all the copper has reacted out of the solution. So we want to proceed on to the next step. This probably will be the longest part of the reaction. Well, maybe not the longest, but it'll take a few minutes to get to this point. What we want to do now is we've used excess zinc. We've got an oxidation reduction reaction going here. We've got zinc metal giving electrons up to the copper 2 plus, so now we go to copper metal and we get zinc 2 plus forming. So we use excess zinc during this reaction. So the problem is in the bottom of my beaker now, I have both copper metal and I have the excess zinc. So we need to get rid of that excess zinc. To do that, we're going to react it with hydrochloric acid. Hydrochloric acid will oxidize zinc metal to give us zinc 2 plus. It will not oxidize copper metal though. So it's a good way to finish our reaction. So what I've done here is I've taken some hydrochloric acid, concentrated hydrochloric acid. I'm going to add it in to my solution. And the hydrochloric acid is going to react with the zinc metal. You're going to notice probably a gas being evolved from this reaction. Okay? I'm going to stir it up, and you're going to see the fine zinc, that's at the bottom of the beaker, the silver zinc, it's going to start reacting away. So you want to leave this to react until you don't see any zinc left at the bottom of the beaker. If you want to speed up this reaction, you can put it onto the hot plate, and it will make it go a lot faster. Okay? I've already done this step of the reaction, so at this point I only have copper left in the bottom of my beaker. So what I'm going to do now is, I've gotten rid of the zinc, I want to just isolate the copper and I want to get a yield out. So first thing I'm going to do is, I'm going to take my solution and I'm going to pour off the top of it. So you want to be careful doing this, you don't want to lose too much of your copper while you're doing this. So got my waste beaker and I'm going to pour off the remaining solution. So it's pretty easy. Now I just have my copper at the bottom of the beaker. Now the problem is right now, I have copper with water. Now if I want to try to dry this, because if I tried to get a yield, we'd have too much water in there and the weight would not be accurate. So we need to dry it. The problem with water is obviously it has such a high boiling point that it's very hard to dry it, or it's going to be very difficult to dry it efficiently in the amount of time we have for this experiment. So what we're going to do is we're going to change the polarity and the boiling point of the solvent on top of the copper. So the first thing I'm going to do is add a little bit of methanol. So I pour some methanol onto the top of the copper. What the methanol is going to do is going to wash away the rest of the water. So a decant. Now all of a sudden I've got my copper here, but it's got no water left on it, it's only methanol on top of it. And methanol has a lower boiling point than water, so it's easier to dry. But we're going to take this one step further. We're going to take some acetone. Now acetone has a very low boiling point, around 55 degrees Celsius, and it's very volatile, so it's very easy to dry. So we're going to pour some of the acetone on top of the copper. You don't need very much, just enough to rinse away the rest of the methanol. And I'm going to pour that off. Now, for the acetone, I'm going to pour it into another beaker. It's an organic solvent. It's not going to go in the same waste as all of our aqueous solvents, so I want to make sure I keep it separate. Pour it off. Now I've got our copper, and it's got a little bit of acetone left on top of it. That's going to evaporate very, very quickly. Now, to even speed up this process, what we're going to do is we're going to put it on the hot plate. We're not going to put the beaker directly onto the hot plate. Whenever you have a piece of glassware that doesn't have a liquid in it or doesn't have a solution in it, it's not a very good idea to put it right on the hot plate. Your odds are you're going to crack and you're going to break the beaker. Potentially dangerous. You're probably going to lose your experiment at that point. You only ever put a piece of glassware on a hot plate when it has a liquid in it, okay, that you can heat up. So what we're going to do to get around this is we're going to take our copper in our beaker and we're going to put it in a water bath. Now this is the water that we had warming through the entire experiment. It's nice and warm. It's probably close to 70-80 degrees Celsius, if not higher. We're going to take our beaker with our copper and the acetone, and we're going to put it on top. What that's going to do is make a nice water bath. It's going to be nice and warm. It's going to evaporate off the remaining acetone, and we're going to be left with a dry sample of copper. So after the copper is dry, this will probably take a couple minutes. Once the copper is dry, you can scoop it out with a spatula, take a pre-weighed weighing boat, weigh that, put the copper inside, get a weight of the copper, and you can get a yield of the copper, and you're done the experiment. Now just remember for this experiment, very important to take good observations. Have everything tabulated before you come in, so have a nice table with the reactions, and then a space where you can put the observations down. Again, very detailed observation. That's an important part of this experiment. You're going to do a yield calculation. And then at the end, you're going to do a brief discussion. It doesn't need to be very long. Again, you want to do good observations in this experiment. But you're going to do a brief discussion on why your yield isn't 100%. So center it around the sources of